Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about machine learning system. This topic is based on a tech blog with the title Model Excellence Score, a framework for enhancing the quality of machine learning system at scale, written by the machine learning engineering team at Uber. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now let's dive in. On the business side, let's take a look at the problem to be solved.
What is Uber and why does it need to use machine learning models?
Uber is a global technology company that provides a platform for ride-sharing, food delivery, and freight transportation. Its business model is centered around connecting users with services seamlessly through their app. To give you a sense of scale, Uber operates in over 10,000 cities worldwide, and as of recent reports, facilitates more than 20 million trips every day. With a market cap exceeding $80 billion, the scale and the complexity of its operation are immense. Machine learning plays a pivotal role in Uber's operation. From predicting arrival time for rides to personalized user recommendations, machine learning models power many aspects of their ecosystem. For example, consider the estimated time of arrival predictions that appears when you book a ride. Behind that seamlessly simple feature lies a sophisticated machine learning model that processes real-time traffic, driver availability, and route data to provide an accurate estimation. This reliance on machine learning enables Uber to deliver reliable and efficient services at scale.
So they built the model, but what's the reason for having this measurement system you mentioned?
That's a great question. Building a machine learning model isn't a one-and-done process. These models require continuous maintenance and improvement to ensure they remain accurate and effective. For starters, machine learning models need constant retraining to account for changes in the data. For example, traffic patterns or user behavior might shift over time, and the model's inputs or features must stay fresh and relevant. Without this, the model's predictions could quickly lose accuracy. Now imagine this challenge multiplied across hundreds or even thousands of models operating simultaneously within a company like Uber. Different teams manage these models, each focusing on various aspects of the business, such as pricing, routing, or fraud detection. If any of these models experience a drop in quality, it could have significant consequences. For instance, inaccurate ETAs might frustrate customers and erode trust. This complexity requires a scalable and systematic approach to measure, monitor, and maintain the model quality. That's where the Model Excellence Score framework comes in. It's designed to tackle these challenges by providing a structured way to assess and ensure the quality of machine learning systems at scale. Now, let's dive deeper into this framework. At its core, the Model Excellence Score framework is designed to measure, monitor, and enforce quality across every stage of the machine learning lifecycle. It borrows concepts and terminologies from the site reliability engineering and DevOps practices, particularly those used to ensure the reliability of microservices in production environments. This framework is built around three fundamental concepts: indicators, objectives, and agreements. Indicators are quantitative measures that reflect specific aspects of a machine learning system's quality. For example, one indicator might track the accuracy of a model's predictions. Another indicator might monitor the freshness of its input features. Objectives set the target range for these indicators, defining acceptable performance levels. Agreement then brings all indicators together, evaluating the overall pass or fail status of a model based on whether its indicators meet their objectives. Imagine a machine learning model at Uber that predicts search pricing. This model might have several indicators, such as the accuracy of the price predictions, the timeliness of its updates, and the robustness of its feature engineering pipeline. Each indicator would have an objective. Say, prediction accuracy must remain above 90%, and feature update must occur within 15 minutes. If any of these indicators fall short, the agreement governing this model would fail, and it will trigger alerts.
That sounds comprehensive, but how does the framework ensure issues are addressed promptly?
Good question. When an indicator falls short of its objective, it's marked as failing, and the framework automatically notifies the designated team responsible for this model. Each model at Uber is assigned a primary ownership team, which is to ensure their accountability. Teams can customize these alerts based on the urgency and significance of their use cases. For example, an issue with high-impact models like search pricing might demand immediate attention, while a less critical model might have a longer resolution window. Another important aspect of this framework is the ability to account for interdependencies between models. For instance, the output of one model might serve as an input for another. If the upstream model's quality declines, it can cascade into the downstream models. To address this, the framework includes a notification system that informs all relevant teams of quality violations, and this fosters a cross-team collaboration to resolve issues. The Model Excellence Score framework also emphasizes principles like automated measurability, actionability, aggregatability, reproducibility, and accountability. These principles ensure that every indicator is measurable and actionable. Metrics can be aggregated for reporting, and ownership is clearly defined. The insights derived from the framework have demonstrated to drive improvements across the company's machine learning systems. Since implementing the framework, Uber has seen a remarkable 60% improvements in overall prediction performance, highlighting the framework's impact on both operational efficiency and technological advancement. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored Uber's Model Excellence Score framework, which is a robust system designed to maintain and enhance the quality of machine learning models at scale. We unpacked its core components, indicators, objectives, and agreements, and explained how these elements work together to ensure the model reliability and performance. The framework plays a crucial role in enabling the machine learning ecosystem to operate seamlessly and efficiently, which drives both innovation and operational excellence. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and we'll see you next week.